In this video, we're going to be learning about electronegativity. Electronegativity is defined as the tendency of an atom to attract a bonding pair of electrons. So in this model, we've got HF, and hydrogen and fluorine, we'll later learn about this in bonding. They form a covalent bond in which there is a sharing of valence electrons. But that sharing isn't a perfect 50-50. In fact, it's far from it. And that's because the fluorine has a stronger pull on those bonding electrons than hydrogen does, and those warmer colors mean that we're in a more negative area, meaning that the electrons tend to be more over here. Hydrogen side, you can see there's just a little bit less electron density there because it can't pull the bonding pair of electrons quite as hard. Hydrogen has a lower electronegativity and fluorine a higher. So let's see this on a periodic table so we can start to identify trends. What we see is that as we go further to the right and up, we have higher electronegativities up until the noble gases. Noble gases, you don't really see electronegativities for them because they don't really form chemical bonds so much in the first place. I find it very difficult to do, so we can't really talk about electronegativity and the ability to attract bonding electrons if there aren't bonds formed in the first place. But let's explain this trend that higher in a group, we have higher electronegativity, and rightward in a group, we have, rightward in a period, we have higher electronegativity. So first, the group trend. Note here, we have nitrogen down to bismuth. Well, nitrogen has a very high electronegativity, and this is owing to the fact that the nucleus can attract bonding electrons because there's not a whole lot of distance between the nucleus and those bonding electrons. As we go down a group, there are more shells, and there's just more space between bonding electrons out here and that nucleus. So in the case of going across a period, we have the same number of shells, whether we're talking about boron, carbon, nitrogen, or all the way up to neon. What differs, though, is the number of protons and the effective nuclear charge. We've already discussed more or less the same thing in terms of ionization energy. The more protons in the nucleus, considering that we still have the same number of shells, the stronger the attraction between the nucleus and something out there. In the case of ionization energy, it's the attraction between the nucleus and the valence electron. In the case of electronegativity, it's the attraction between the nucleus and bonding electrons. But what we can see is that fluorine, with its 9 protons, is going to have a substantially higher electronegativity than boron with its 5, or lithium with its 3. And so that explains electronegativity. Hope this video has helped. Feel free to leave any questions or comments in the comment section below.